Let's look at section 6.5, lines parallel to the same line. There is a theorem here. Lines which are parallel to the same line are parallel to each other. So abhi is figure mein if we see, let's say L and M are parallel to each other. So L is parallel to M, and let's say M and N are also parallel. Okay. Now when we say parallel, हमें intuitively पता है कि what it means for lines to be parallel or line segments to be parallel. But parallel cannot be quantified directly. See, you have to have certain quality that can be measured. So let's say L and M के बीच में perpendicular distance. That could be one way to think about it. Or there's some type of angle which are related, right? So the way to prove a theorem is by considering a quality that can be measured, that can be quantified. So parallel है, but does not mean कि equidistant है. Teen lines, right? So L and M can be parallel. Okay, fine. There's probably a distance A between them. M and N are parallel. There may be a perpendicular distance B. But A and B में क्या relation हो सकता है, right? A and B अगर equal है, it means कि जो lines है उन दोनों का बीच में distance same है, but ज़रूरी नहीं है कि वो parallel हों. So I'm just giving you an example on how to think about it. So to prove this specific theorem, what we'll do is we'll drop a line T, a transversal line T across these three lines. और उसमें यहाँ पे angles बन गए 1, 2 and 3. Okay, so now we know that L and M are parallel, which means angle 1 is equal to angle 2. Same side वाले angles are equal. M and N are parallel, which means that angle 2 is equal to angle 3. अब इस दोनों को combine करेंगे, it means that angle 1 is equal to angle 3. So by reverse of this transverse line wala theorem, we can say that, hey, because angle 1 and angle 3 are equal, we can say that L is parallel to N. Therefore, this theorem is proved. So we should always keep in mind that for most theorems, the way to prove is to identify a common quality against the specific line segment or a line or triangle, whatever the object is. We have to find a common measurable item and then see what is the relation between them. So this closes theorem 6.6. In example 4, it says that in figure 6.1, if PQ and RS are parallel and angle MXQ is 135 degrees and MYR is equal to 40 degrees, then find XMY. So this is the angle that we are supposed to find, right? So let's say the way to solve this problem is that, hey, we have to come up with some equation such that angle x and y is part of it. Only then we'll solve that polynomial. Or a linear equation in this case, right? Secondly, we know the relation that PQ and RS are parallel, which means if there was a transverse line between these two, then we can form certain relation between the angles, right? So let's say हमने, if this is what we had done, then angle MXQ, this one, is equal to angle this one, right? As you can see. But in this case, X and Y is not part of the relation. So in order to bring this particular angle, we'll draw AB, which is a line parallel to PQ and RS. Okay, so once you do that, you can use theorem 6.6 and arrive at certain relations between angles. So the first relation will be angle MXQ plus angle XMB is equal to 180 degrees, right? Why? See, when angles are parallel, the opposite angles are equal, and because it's these angles are on a line, the sum of these two angles will be 180 degrees. So in other way, we can say that angle MXQ plus angle XMB is equal to 180 degrees. Similarly, second equation will be angle MYR is equal to angle BMY. See, the way I have selected these equations is such that either angle XMY wholly is there, or the parts of these angles are in these equations. Okay, so now we know MYR is equal to 40 degrees. Therefore, angle BMY is equal to 40 degrees. Next is MXQ is 135 degrees. So we know this, right? 135 degrees. So when you solve this equation, angle XMB is equal to 180 degrees minus 135 degrees, that is 45 degrees. So angle XMY is equal to 40 degrees plus 45 degrees, that is 85 degrees. So this is the solution. In example 5, if a transversal intersects two lines such that the bisector of a pair of corresponding angles are parallel. So you have two lines, let's say PQ and RS, and there's a transversal AD such that the bisectors of pair of corresponding angles. So corresponding angles, we can look at this angle and this angle. Now you have to look at bisector of these angles. So bisector BE and CG are parallel. So we know that angle, line segments BE are parallel to CG. We know that two lines are parallel, which means that there is some relation between the angles, right? So for these two, there is, so AD is a transversal line between these two, okay? So angle EBC is equal to angle GCD, basically this and this, right? Because lines are parallel, that's why. But here the example is asking us to prove that the two lines are parallel. Basically, we have to prove that PQ is parallel to RS, right? So for the using the transversal AD, we have to find the relation between angle. So let's just redraw this very simply, right? You have PQ and RS, and you have A and D. PQ, RS. This is B and this is C. So between, for these, there are angles, this and this, that are equal. So ABQ is equal to angle BCS, which also means that half of ABQ is equal to half of BCS. Half of ABQ is EBQ. Angle EBQ is equal to angle GCS. So this is one relation that we know. Now coming to EBC and GCD. Now EBC is comprised of angle EBQ plus angle QBC, and GCD is comprised of GCS plus angle SCD. We know that these two are equal, okay, from sorry, we don't know that these two are equal. However, this is what we are supposed to prove, right? We looked at how to arrive at PQ equal to RS. PQ is parallel to RS. So now we look at, okay, QBC and SCD make, we have to find some relation. Okay, so Q, B and C, this, and SCD is this. Now QBC can be written as 180 degrees minus angle ABQ, and angle ABQ is nothing but twice of angle EBQ. Similarly, angle SCD is equal to 180 degrees minus angle BCS, which is equal to twice of angle GCS. So we put these two in this equation. Okay. Therefore, angle EBQ plus 180 degrees minus twice of angle EBQ is equal to angle GCS plus 180 degrees minus twice of angle GCS. So 180 degrees will be crossed out, and minus angle EBQ is equal to minus angle GCS. We'll remove these negative signs, or we can just transpose them. So angle GCS is equal to angle EBQ, right? Which is, this is the same as what we need to prove in order to get PQ is parallel to RS. So in these questions, the approach is to find relations between the angles between parallel lines, and you can think of what angles to arrive at by looking at what is to be proven. In example 6, it says that AB is parallel to CD. So this is parallel to CD, and CD is parallel to EF. CD is parallel to EF. So by theorem 6.6, we can say that AB is parallel to EF. Okay. Also, EA is perpendicular to AB. So EA is perpendicular to AB. So this is your 90 degrees angle. If angle BEF, this is given, we have to find value of X, Y, and Z. Alright, so here we have three parallel lines, AB, CD, and EF, and we have two transversal lines, AE, which is perpendicular, and we have EB. Alright, so let's first take just this. So since this is 90 degrees, this is also 90 degrees, and this, these are also 90 degrees. Therefore, we know that angle Z plus angle DEF is equal to is equal to 90 degrees. Therefore, Z is equal to 90 degrees minus 55 degrees. Therefore, this is 35 degrees. Now, the next one is so Z is clear. Now X and Y. See, BDE, it's a transversal equation, and AB and CD, they are parallel lines, which means X is equal to Y. So now we have to basically just find value of either of these. Here we know that CD and EF are parallel, right? These two are parallel and this is a transversal, which means that angle Y plus angle DEF, these are equal to 180 degrees. Why? See, this angle and these angle, their corresponding angles, they'll be equal. And because this is a straight line, this is a straight line, so sum of this and this will be 180 degrees. So therefore, Y is equal to 180 degrees minus 55 degrees. So the value will be 125 degrees. Alright. And therefore x is equal to 125 degrees. So we have value of all three. X is 125 degrees, y is equal to 125 degrees, and z is equal to 35 degrees.